Hello everyone and welcome back. In today's video we're going to cover constant acceleration, in other words SUVAT equations. We know that constant acceleration is when an object is speeding at the same rate. We're going to learn what is SUVAT and how we can apply the knowledge we have from the questions in the exam to these equations to finally solve the questions. Now this is part 2 in the mechanics series. I highly recommend you watch the other video to learn the basic definitions in mechanics. Without further ado, let's begin with the video and let's do this question. If a cyclist is moving from A to B in 6 seconds with an initial velocity at point A of 5 meters per second and final velocity at point B of 10 meters per second, what is the distance in meters from A to B? Let's go through each variable we have. SUVAT. What does SUVAT actually mean? SUVAT stands for following. S is displacement in meters, U is initial velocity, and what's the unit? It is meter per second, and V is final velocity, and that is also in meter per second, and this one is acceleration, and it's meter per second squared, and this finally is in time, and it is in seconds. We need to know what do they mean. We need to know their units because these are the SI units, the standard international units. So if in the question you might get the variable in other units, for example time could be in hours, but the answer should be in seconds, only if the exam questions specify otherwise. How do we put all of this into equations? We have the basic equation. S is half U plus V times T. Displacement equals half between bracket initial velocity plus final velocity close the bracket times time. The second equation, this ut plus half at squared, s equals vt minus half at squared. Fourth one is v squared is u squared plus 2as, and the last one is velocity equals u plus at. Final velocity is the initial velocity plus the acceleration times time. Data sheet or the formula booklet. So these are in the exam, but these are provided, but you should know how to apply them. We're going to use this question. We're going to use one of the equations. Now, just to let you know that in some questions you might use 1, in some questions you might use 2. Unlike any other equations, you might have to rearrange to find other variables, so it's not always as straightforward as. Now we have a cyclist and they are moving from A to B in 6 seconds. So first of all, whenever we have a SUVAT question, we write SUVAT to make it clear of what variables we have, what values we have, and what we need to find out and what we don't have to. First of all, we have 6 seconds with an initial velocity at point A of 5 meters per second and final velocity at B is 10 meters per second. What is the distance in meters from A to B? Now that's what we're trying to find. This we do not need acceleration. The basic equation we have learned is displacement is half u plus v times t. So we're going to use half times 5 plus 10 times 6. Half times 15 times 6. You should get 72 meters. And that is the answer for this question. This one is very straightforward. It's a good start, but we're going to move to another challenging one. In this question, if a cyclist accelerates from 2 meters per second at rate of 0.05 meters per second squared, how long will it take for them to travel 1.5 kilometers? First of all, I noticed that the kilometer is not in SI units, so I need to convert it to meters, which is going to be 1,500. I need to write SUVAT. Always. Don't think it's a waste of time, but rather it's a clear method of laying out all the values you have and seeing where to work out and which value to find. It basically converts all the words into numbers, and that's what we like in math. We know that displacement is 1,500 meters. We know that the initial velocity is 2 meters per second, and we know that the acceleration is 0.05. Do we know the time? That is what we're trying to find, so we do not need the velocity. Now we have initial velocity, we have acceleration, we have time and displacement. We can use the second equation, this equation. So we can use this equation, s equals ut plus half at squared. So ut half at squared. Let's apply all the values we have. Let's substitute. 1500 to t plus half times 0.05 t squared. So we're going to have 1500 equals 2t plus 1 over 40 t squared. Now we can rearrange that, okay, to make it quadratic formula, and let's bring the 1500 to the equation and make that equal to 0. Now to get rid of the 40, to get rid of the fraction in the equation, we can multiply all the terms by 40. This is going to be t squared plus 80t minus 60,000 equals 0. You can solve this equation by formula or by factorization or by completing the square. But for time purposes, we're going to solve it by the calculator equation function. You go to menu setup, choose A. It is the button with the between bracket negative sign. It's drawn, the A is drawn in pink, so you press that button. You go to polynomial number 2 and then press 2 because the degree is quadratics. It's 2, and then substitute in the values. You should get 208.19 etc. Second value negative 288.19 etc. in seconds, and we can clearly see what is the answer because this is not valid because time cannot be negative, so therefore the answer is this. T1 time equals 208.19 seconds. That's it for today's video. Don't forget to watch other videos in the playlist. Don't forget to comment any questions you have. Thank you very much for watching. See you in the next one. Bye.